Let's evaluate a definite integral with a radical together. Now, if you'd like to try this problem on your own first, go ahead and pause the video so you can give it a try. Otherwise, let's get into it together. So here's a definite integral that we're going to be working with here. So first, I'm just going to go ahead and copy down this problem. And I think I'm going to go ahead and just rewrite this using some exponents. So starting off, if we just look at the square root of x, I think it's good to remember that if we have the square root of x, that's in radical form, but you can also write this in exponential form as x to the 1/2 power. And what about this 1 over x? Well, when we have this 1 over x expression, keep in mind that we can really write that as x to the negative first power. So let's go ahead and rewrite our problem using these exponential forms instead. All right, now that we have everything in exponential form, let's go ahead and just distribute this x to the 1/2 power to both of these terms on the inside of the parentheses. So when we do that, we have x to the 1/2 power times 1, that's still going to be x to the 1/2 power. And when we distribute this x to the 1/2 power and multiply that by the x to the negative 1 power, just go ahead and add those exponents together. So that's going to be x to the negative 1/2 power, since a half minus 1 is going to be negative a half. So now that we have a difference, this is going to be easier to integrate. So we can go ahead and just take this x to the 1/2 power, and if we go ahead and take the integral of that, keep in mind we're going to add 1 to that exponent using that power rule, and that's going to be 1/2 plus 1 is 1.5, or 3 over 2, and we have to make sure we divide that by that 3 over 2, right? And when we do that, the dividing by 3 over 2 is going to be the same thing as multiplying by 2 over 3, so that's going to be 2/3 x to the 3 over 2 power. And hopefully this makes sense as the antiderivative, because if you were to take the derivative and use the power rule, this would come down in front and multiply by 2 over 3, and those are multiplicative inverses, so that would just equal 1. And you take away 1 from 3 over 2, you get 1/2. Similarly, if we go ahead and take the antiderivative or the integral of this expression over here, then if we take this x to the negative 1/2 power, if we go ahead and add 1 to that, that's going to be negative 1/2 plus 1 is going to be positive a half. Then we're going to have to go ahead and divide by that. So if we divide by a half, that's the same thing as multiplying by 2. So that's going to be 2x to the, and then we said it's going to be to the 1/2 power. So let's go ahead and raise that to the 1/2 power. All right, so we now know the antiderivatives of each of these pieces. So let's go ahead and solve this. So we integrated this x to the 1/2 power and got this 2/3 x to the 3/2 power. That's going to be this right here. And then what are we subtracting from it? Well, when we integrated this x to the negative 1/2 power, we got 2x to the 1/2 power. So let's go ahead and write that. At this point, we are done integrating, so we just have to go ahead and evaluate this on the interval from 1 to 4. Now, I don't really feel as comfortable evaluating in exponential form as I do in radical form, and maybe you're in the same boat. So what we're going to do here is I'm going to turn this back into radical form. So we have this x to the 3 over 2 power. Right? And if you feel comfortable keeping it in this form, that's fine. But I think there may be some other people out there that are more comfortable in radical form as well. So instead of writing x to the 3/2 power, we can write this as x to the 1/2 power multiplied by 3, right? So we're just separating because 1/2 times 3 is just 3 over 2. Now you can either write it as this x to the 1/2 power times 3 or x to the 3 times 1/2. So you can write the 3 or the 1/2 first, it doesn't matter each way. If you're going to write this first way here, that's fine. We're basically saying we're going to take the square root of x, right? And then we're going to raise that to the 3rd power. So that's one way that we could write this. Or we can say that this is going to be x to the 3rd power, and then we're going to take the square root of it, right? Either version of this is going to be fine, so that's up to you how you want to write it. And this one's a little bit easier to work with just because we have a unit fraction here, so we have x to the 1/2 power. So if we go ahead and write x to the 1/2 power in radical form, that just means we're taking the square root of x. So going ahead and rewriting this in radical form here, for this x to the 3/2 power, this one right over here, I'm actually going to use this form here because I like to make the number smaller first instead of making it bigger than taking the square root. Let's make it smaller than cube it. So if we go ahead and rewrite this, this is going to be 2/3 multiplied by the square root of x. But this is going to be cubed, right? So make sure we put that in a hug or a parentheses there. And then we're going to go ahead and write minus 2 multiplied by the square root of x. So let's go ahead and use this version instead, and then we'll evaluate this from the interval from 1 to 4. All right, so at this point, when we evaluate from the interval from 1 to 4, let's go ahead and just plug in 4 into our expression first, and then we're going to plug in 1 to our expression, and we're going to find the difference between those two expressions. So let's go ahead and write that down. So this is what it looks like when we plug in 4. And this is what it looks like when we plug in 1. Let's go ahead and just find the difference between these two and evaluate this now. All right, let's just start with one of these parentheses at a time, or one of these groupings. And in this first one, if we go ahead and take the square root of 4 first, that's going to be 2. So this is going to be 2/3 multiplied by this 2 to the 3rd power. And we are also going to have this 2 multiplied by the square root of 4, which is just 2. So it's going to be 2 times 2. Then we'll go ahead and take this 2 and raise it to the 3rd power. That's going to be 8. So that's going to be 2/3 multiplied by 8 here. And if we multiply this 2 and 2 together, that's going to be 4. So we're going to go ahead and take away 4. Now 2/3 times 8, that's going to be 16/3. So we'll go ahead and write 16/3 here. Minus, and then 4 is the same thing as 12/3, right? And if we go ahead and take away 16/3 minus this 12/3, that's going to end up being 4/3. Now our other grouping here, we have the square root of 1, that's just going to be 1. So we're going to have this 2/3 multiplied by 1, and then minus, we have 2 multiplied by the square root of 1, which is just 1. So we have 2 multiplied by 1, right? Then each of these are just multiplying by 1, so we're just going to have this 2/3 minus this 2. Now 2 as a fraction is 2 over 1, which is really just 6 over 3. So I'm just rewriting that in a fraction form. And then 2/3 minus 6/3, that's going to be negative 4/3. All right, so this whole thing over here just boiled down to being 4/3, and then this thing over here just boiled down to being negative 4/3. Keep in mind that we're subtracting these from each other, so what we have to do next is just take this 4/3 that we have from the first part, and let's just go ahead and take away this negative 4/3 that we got from when x was equal to 1. So 4/3 minus this negative 4/3, that's just going to be 4/3 plus 4/3. We have a final answer here of 8/3. Alrighty, so this right here would be the value of this definite integral. Now what I think made this specific example of a definite integral a little bit more tricky was the fact that we had radicals in there as well as some negative exponents. So hopefully it was helpful that we went over some of those exponent and radical rules and converting from exponential to radical form and back and forth and so forth. So we could go ahead and focus more on the calculus-based ideas where we were taking the integrals and then evaluating it based on the interval that we had from 1 to 4. So that wraps up this particular example. If you feel like this video helped simplify the process down of how to solve this problem, feel free to let me know in the comment section down below and give this video a thumbs up as well. And as always, keep up the great work that you're already doing, and I'll see you in the next one.